Hello everyone, I'm Pushpita. My teammates are Santosh, Vinod, and Srija. We are Team Amigos here presenting the project Detecting Network Intrusions and Analysis of NSL-KDD Dataset. So coming to the introduction, we have the intrusion detection, which is the process of identifying malicious activity or unauthorized access in a computer network. Intrusions can also include attacks such as DOS, denial of service, or U2R, user to root, R2L, remote to user, and also probe. So there are like two main types of intrusion detection, which is signature based and anomaly based. Intrusion detection is a critical component of network security, and because it can help identifying and responding the security incidents in a real time. And also, DOS attacks aim to disrupt the availability of network resources by flooding the network with traffic. And also, we have like probe, which are used to gather information about a network's vulnerabilities and configuration. We have remote to local attack, which target vulnerabilities in the network's authentication and access control to gain unauthorized access. We have user to root, which can help exploiting the vulnerabilities in the system to gain root level access. So we use NSL-KDD dataset, which is a modified version of KDD Cup 1999 dataset, which is widely used benchmark dataset for intrusion detection research. So coming to our dataset, it includes a pre-processed version of KDD Cup 1999 dataset, which has been normalized and deduplicated to reduce noise and also to improve the accuracy. So the dataset is widely used for the intrusion detection research, which can help evaluating the performance of different machine learning algorithms like random forest, naive bayes, and k-nearest neighbor, support vector machine decision trees, logistic regression, and also artificial neural networks. So here is our problem statement in which in a given a network traffic data set, we have developed a machine learning model which can accurately classify each network connection, which can either be classified as normal or malicious. And also the model should be able to identify different type of attacks, which was discussed below. So we have the data set here, the NSL-KDD, which I have discussed earlier, and also it is mainly used to improve the version of KDD Cup 99 data set, and also it helps to mainly include the network traffic data from a local area network, and also by simulating the environment that is designed to resemble a typical US Air Force LAN. And also this data set has been pre-processed to eliminate redundancy and inconsistency in the original KDD Cup 99 data set. In this data set, we have like 41 features and a class label indicating whether a network connection is normal or an attack. And also this data set consists of training data set of 125,973 instances and a test set of 22,544 instances. So we have data description. We use two different data sets. One is train data set and the other is test. So we have the variables of train data set, which was discussed below. And then we have variables of test data set and train data set. We also have the shape of training data set and test data set after removing the null and duplicate values. And these are the columns of existing train and test data set. So we have training set attack distribution. So here in the bar plot, we can see the train attack counts and test attack counts, which are counted of each attack type in the training and test data set. And also we have test set attack distribution in which we have generated a bar chart of the attack distribution in the test set. It first retrieves the attack count for each attack type in test set using the value counts method. So coming to the data pre-processing, it's a crucial step in machine learning, which involves transforming raw data into a suitable format for building predictive models. So in order to mainly improve the accuracy, we have also performed checking null values and removing the duplicate rows, and also like giving the column names for both training and test data set. And also we have identified categorical features, and we have added 6 missing categories from train set to test set. So here we have identified categorical features for training set. In training set, we have feature like protocol type, which has 3 categories, and we have surveys, which are 70 categories, and we have flag having like 11 categories and attack with 23 categories. We can also see the distribution of categories below. And here we can see the identified categorical features for test data set. We have features for protocol type having like 3 categories, and surveys having 64, and flag having 11, and attack having 38 categories. So coming to the continuation, we have like one-hot encoder. We have also used one-hot encoding, also known as one-of-k encoding, which is a technique used to convert categorical features into binary features. And we also use label encoder to transform the categorical data into numerical data. In label encoding, each category is assigned a unique numerical value, where n is the number of unique categories in the data set. So we use the following attacks, which are classified into 4, like denial of service, DOS, we have like prob, we have remote to local, and also we have user to root. So here is a pie chart for the distribution of attack types in the training and test data set. We can see the pie chart having attack percentage for train and test data sets. So my teammates are going to present the rest.
Hi, my name is Santosh, and now I'm going to continue from dataset distribution as binary classification in type of normal versus other attack. So here we'll be doing a process of taking a normal versus the other attack type. Here, after splitting the dataset into the attack types of DOS, prob, and R2L and U2R. Here I'll be comparing it with if it's 0 or the other attack type of DOS 1. And here the next step will be for prob and R2L and U2R. And on right side, if you see, we have this code snippet where we will be doing the process which I have explained. And after splitting the data set, we can see the dimension for the DOS, prob, R2L, and U2R for train and also as test. So after dividing it by attack, we'll be performing standard scalar. Standard scalar is nothing but it is used to resize the distribution of values so that the mean of the observed values is 0 and the standard deviation is 1. So here we perform standard scalar on each and every attack of data frame. So next step was to find the feature importance. So we used random forest, the most popular machine learning algorithm that can be used for both classification and regression tasks. So it is an ensemble method that builds a multiple decision trees and combines their predictions to produce final output. So here I used random forest for finding feature importance. So the feature importance score is calculated by averaging the decrease in impurity or entropy over all decision trees in random forest. So the scores are then normalized so that they add up to 1. So after building that random forest for feature importance, these are the top 25 features for all the features which are added. Next, we'll be performing hyperparameter tuning. So hyperparameter tuning refers to the process of optimizing the hyperparameters of machine learning model to improve its performance. So hypermodels are models parameters that are not learned from the training data, but are set manually by the user before training the model. So hyperparameter tuning is used to find the optimal values of the model that can maximize the performance, and by finding the best hyperparameters, the model can generalize better and produce more accurate predictions. So here there are several types of hyperparameter tuning, but in our project, we have used grid search CV and random search CV. So grid search CV, in this method, a set of hyperparameters is defined and the model is trained and evaluated for each possible combination of parameters. And the next type is random search. In random search, that randomly tries to perform search on randomly get the random samples hyperparameters from predefined search space and trains the model with each combination. So these type of hyperparameters include regularization parameters, learning rate, and also minimum sample splits, max depth, and minimum sample split and the other hyperparameters. So here, if you see the results for random forest hyperparameter tuning is n estimate is 150 and minimum sample splits is 2. And for logistic regression, C value is 10 and penalty is L2. And for decision trees, it's minimum samples 2 and maximum depth is not given, and citation is entropy. So if you see the code snippet here, we have performed hyperparameter tuning, and I have used random forest classifier for here, and I used random search CV. Here, if you see, I have performed hyperparameter tuning on random forest, and we can see the best hyperparameters mentioned at below. N estimate is 150 and minimum sample splits is 2 and max depth is not given, and the best score was 9986. So model accuracy is around 99. It's close to 100. So here we have plotted confusion matrix. So confusion matrix is commonly used to evaluate the performance of binary classification models, where there are two possible outcomes, positive and negative. So the four cells in the confusion matrix are true positive, false positive, true negative, and false negative. And here, if you see, there are four types of classification. As I explained before, we'll be trying to develop a model which will try to predict all types of models, all types of attacks. So if you see, there are four labels, and the confusion matrix in shape of 4 into 4. And here, if you see, we have printed the classification report, which shows precision, recall, and FN score. And we can see the accuracy near to 1. That's because they rounded off the value of accuracy. And I have performed hyperparameter tuning for logistic regression. And here, if you see, as I used random search CV for random forest, I have used grid search CV here, so that it will be we have used the both techniques. So here, if you see, the params grid was 0.1, 1, and 10. Penalty was L1 and L2. By performing grid search CV, after performing grid search CV, we try to find the best score. And if you see here, the best parameters are C10 and penalty L2, and model accuracy is 80. So again, we have printed the classification report, and we can see the accuracy around 81. And the same confusion matrix 4 into 4 was predictive for the attack types. So the next model what we designed here was decision trees, and I have used random search CV for hyperparameter tuning, and the params grid, you can see the citation as Gini, entropy, and the maximum depth as 5, 10, 15, 20, and the others. And the best type after training the random search CV on for decision trees, we see the best parameters as minimum splits 2, maximum depth not given, and citation entropy. And the model accuracy was around 99.6, so it was close to 1. And I have plotted confusion matrix as the previous models, and we can see the accuracy was around 99, so we can continue. So here I tried to compare all the models. Like we are trying three models here. That's because I tried to we tried to merge all. We tried to predict the outcomes for all the attacks, not binary classification. So for all the attacks. So if you see the based on accuracy scores present in the table, the random forest model is best with accuracy of 99.85, followed by decision trees with accuracy of 99.67, and logistic regression with accuracy of 80. So random forest has high accuracy, logistic regression has low accuracy, decision trees has high accuracy near to random forest. So selection of best model ultimately depends on specific requirements, and it based on our requirement here, random forest performs well. So feature selection by attack. So as we can see previously, we have developed models on all types of attacks. Now, when it comes to the next step, we'll be concentrating on attack on each of the attacks. So what I have done was, if you see the previous task, we have developed an XDOS data frame where we have concentrated on particular attack. So it'll what it does was it'll have the data of normal, whether it's normal or DOS. So it's a kind of binary data set. So I have performed feature selection for this particular DOS type attacks, and I used random forest. And if you see here, this is feature importance for DOS attack type. And if you see the source bytes have highest feature importance for predicting the device attack type. And this is the feature importance for R2L. And in this similar fashion, we'll be finding for the other attack types. So after finding the feature importance for all the attack types and by using random forest, these are the features selected for DOS. And if you look closely, the features for the DOS and denial of service and R2L was different. If you see the source bytes has highest importance, but R2L, the level has highest importance for predicting. Uh, yeah,
Hello
so
everyone, I am Srija Nanuri. Now we'll make use of above selected features and try to build the models for each attack type. Pushpita and I did model building using three models. Those are random forest, naive Bayes, and nearest neighbor. The first model is a random forest model. Random forest algorithm is a popular machine learning algorithm that is widely used for classification and regression tasks. It is an ensemble model that combines multiple decision trees to improve the accuracy and generalization of the model. For classification tasks, the output of the random forest is the class selected by most trees. For regression tasks, the mean or average prediction of the individual trees is returned. Each decision tree in the forest is trained on a randomly selected subset of the training data and the randomly selected subset of the input features. And here the previous slide, looking at this code segment is using the random forest classifier algorithm from the scikit-learn library in Python to train model for intrusion attacks such as DOS, prob, R12, and U2R. The first line creates a new instance of the random forest classifier class with the default hyperparameters and a random state of 0. And there are four separate instances of the random forest classifier class, one for each type of intrusion attack. We have four intrusion attacks. And the next four lines fit each of the four models to their respective training data using the fit method of the random forest classifier class. And the y underscore dos, y underscore prob, y underscore rtl variables are converted to integers using the as type int method, as the random forest classifier algorithm requires integer labels. And then we use the predict method to make predictions on the test data. The code segment which we see here, um, this is using the crosstab function. The predicting method of the trained random forest model for the DOS attack type is used to make predictions on the test set of input features, and the resulting predicted labels are stored in the y underscore DOS predicted variable. The crosstab function from the pandas library is called with the actual labels of the test set and the predicted labels. The row names and the column names parameters are used to label the rows and the columns of the confusion matrix respectively. The resulting confusion matrix is a table that shows the number of true positives, false positives, true negatives, and false negatives for the classification problem. And then here we generated a confusion matrix for all the four intrusion attacks. Um, Going to the next slide. This code segment is using validation to provide a more robust evaluation of the performance of the random forest model for the DOS attack type by repeating the evaluation process multiple times with the different subsets of the test set and averaging the results. This can help to provide a more accurate estimate of how well the model is likely to perform on new unseen data. And also by looking at the accuracy score for the random forest model trained on the DOS attack type ranges from 0.99831 to 1.00353 with 95% confidence. Here, actually, we first evaluated the metrics on the DOS confusion matrix and then evaluated the metrics for all the three confusion matrix. Appended them accuracy score across all folds of cross-validation in CLF accuracy list and similar way for precision recall and the list. Coming to the next slide, and the next model is the naive-based model. A naive-based model is the classification algorithm that makes prediction by calculating the probability of each class given a set of input features. Naive-based, it is based on the Bayes theorem, which states that the probability of the hypothesis is proportional to the prior probability of the hypothesis time, the likelihood of the evidence given the hypothesis. In the context of intrusion detection, the hypothesis whether the network traffic is normal or anomalous, and the evidence is the features of the network traffic. Naive-Bayes is a popular and effective algorithm for intrusion detect, and it can be used in many research studies and commercial products. In the similar way we have done for the random forest, we did the same. We performed calculating the evaluation of metrics such as accuracy, precision, recall, and F1 score using the same code. And also we found the accuracy. Okay. Coming to the next algorithm, the k-nearest neighbor algorithm. The k-nearest neighbor algorithm classifier is a simple algorithm that classifies a data point based on the class of its k-nearest neighbors. In other words, it identifies the k-training examples in the dataset that are closest to the new data point and predicts the class of the new data point based on the most frequent class among those k-neighbors. Some of the KNN advantages are its simplicity and ability to handle nonlinear decision boundaries. And in the similar way, we found the confusion matrix for all the four types: DOS, prob, R2L, and U2R. And here is the output of predicted attacks, actual attacks. Zero, we named true as a 0 and the false as a 1. These are the confusion matrix of all the four intrusion attacks. And the next models will be continued by my friend.
Hi, my name is Vinod Kumar. So till now, all other models has been explained by my teammates. Now I'm going with the SVM. SVM is a support vector mission. So support vector mission is a we applied on a supervised machine learning algorithm. So it can be used for classification regression as well. So as based on our data set, it's working on a classification data set. So on top of the classification, we can able to try for a linear and non-linear using the SVM. So coming to linear and non-linear. So linear is like separable with the hyperparameters, and coming to the non-linear, we can't able to separable in a linear way. So that's why we make it as a non-linear. So based on the hyperparameters, it can be measured like that. So this SVM is a most useful and a very efficient classification model, which can be which can give a good results for high dimensional data sets. So coming to the code wise, we have created a SVC, like a SVM model using the linear kernel. So if you find the first 4 lines, we have partitioned the attacks like a DOS attacks, prob attacks, R2L, and U2R. These are the attacks we have created, and we created the models, and along with that, we got the outputs for corresponding models. So after that, we have fitted that models with corresponding parameters, what we have found in previous slides. So this is how we have performed the SVC, and we have done classification for all the attacks, and we have figured out, and then we have calculated in the code. So in the similar manner, we have done the modeling for a decision tree. So decision tree is another model. So this can be also used for classification and the regression. But this decision tree, if you see the structure of the image, it will start with the parent and will go with the child. In a similar way, it'll always have a different children. So the final leaf loads is gonna have the output classes. This is how the decision tree will be formed. So coming to the model creation, we have used the decision tree classifier as like how we have explained in another all other models. We have divided DOS attack, probe attack, R2L, and U2R, all the attacks, and then we fitted it with corresponding inputs like whatever we got the parameters for feature attacks, whatever we got in a model creation. So these are we perform the classification, and then we got the results. And along after getting the results, we perform the accuracies and confusion matrix, everything we have plotted. And after that, we went to the logistic regression. Logistic regression is used for a binary classification. So if you consider our model, we are doing a binary classification. Like we are taking the one model and then we are taking the one attack. We are keeping all other attacks in another set. So keeping that in mind, we have made it as a binary classification. If you find like a logistic regression for a clear explanation, finding a email which is going to be spam or not spam in a similar way, like you are going to have statistic method, whether it is yes or no. In a similar way, we gonna make it as a whether this attack comes under whatever the desired attack or not. So in that way, we gonna use this logistic regression and go to the code. So we have performed the logistic regression, and you can able to see the we have performed the max iterations of 100, and we got the same results as like what we have given feature attacks for a corresponding DOS, probe, R2L, and U2R. So all these we have defined, and then we got the results. We perform the confusion matrix and accuracies, everything we have calculated. After doing that, we have decided to go with a deep learning algorithm as well. So we consider an artificial neural network. So artificial neural network, which works like you are gonna give an input, and with weighted inputs you are gonna give, and you will get the output. So in between that, you will have a hidden layer. So those hidden layers will be the hyperparameters for that. So there are so many hyperparameters is there to process the ANN, like learning rate, etc. So many we can able to include based on our requirement. So when you get the output from one layer, and again you are going to give that to the another layer in a similar way, like the output from the previous step has to come to the input for the second step. This is how the ANN will work. So we have a different activation functions in ANN. So we have a ReLU, sigmoid, so many activation functions are there. So we have decided to go with a sigmoid function. Why? Because we are working on a binary classification. So sigmoid function will mainly work for a binary classification. Keeping in that mind, we have created the model with a sequential order, and then we created the model, and then we applied the same how we have given the inputs like DOS, probe, and U2R and L2R. So we have created that, and then we can find the all confusion matrix, accuracies, everything we have calculated for ANN as well. But calculating all this, we can come to the conclusion like it's better to compare all the models and all the results. So we have done all the metrics comparison in the next slide. So if you check for DOS, so we have performed the random forest, naive bayes, KNN, SVM, decision trees, logistic regression, and ANN. If you see the accuracies for them, mostly the random forest and KNN decision tree is having the highest values. It's like 99%. If you go with the accurate result, we were found random forest has a high accuracy for all the models. For DS, DOS, and probe, and U2 or L2. So we have made all the calculations, and we have made it as a tabular column for accuracies, precision, recall, and F1 scores. So this is how we have performed our project, and then we are done with the project. Thank you, Professor.